So where are we up to this point? We've done hepatitis B, DPT, Hib. We've talked about polio. We've talked about the pneumococcal vaccine. That's the Prevnar. We've talked about polio. We've talked about the pneumococcal vaccine flu. Okay, chickenpox, measles, mumps, and rubella. We're going to start with chickenpox. Okay, the chickenpox vaccine, the chickenpox, the disease. Chickenpox is caused by a varicella vaccine. Okay, lesions erupt in crops. The majority are crusted over by 6 days. Infection is self-limiting and with very rare complications. Treatment is supportive and symptomatic. Okay, this was a normal childhood disease. Kids ages, 1 to 9, that's where the prevalence is. That's the prevalence rate of almost 100 per 100,000. This was where the kids had normal childhood diseases. That was part of it growing up. The chickenpox vaccine was developed in 1973, and it's a live virus vaccine that's attenuated, which means that it's passed through a series of animal tissues over and over and over and over and over and over again until it becomes weak enough that when it gets injected into the rabbit or guinea pig or whatever animal they're using, you can develop an antibody response without developing the disease. That's what attenuation means, is that you take a live virus and you grow it over and over and over and over and over and over and over again, and somehow in that regrowing process it loses its potency, it loses its strength. But the other thing that it does is it passes through each one of those tissues, is it has the potential of picking up that little bit of DNA of each one of those tissues as it passes through too. And that process is called transcession. And we know in immunology that that is a very real thing that can happen. Each dose of chickenpox vaccine also contains table sugar, gelatin, neomycin, fetal bovine serum, a little bit of human diploid DNA. Good thing is it has no thimerosal. That's a good thing. Now, I'm not going to talk any about fetal bovine serum in this presentation, but in the other video, the CDC document video that we do, goes into a very long explanation about the problems with having fetal bovine serum as a type of solution that these vaccines are grown in and the potential for viral contaminants out of that. Okay, so what are some of the problems with the chickenpox vaccine? Number one, well, let's see, the antibodies only last for about 10 years, so you don't have lifetime immunity. Okay, and vaccinated kids become non-immune adults. And the risk for hospitalization of adults who acquire chickenpox is almost 20 times greater than the risk of a kid who gets chickenpox. And the risk of severe or fatal disease increases from 0.7 per 100,000 to 25 per 100,000 in adults who have chickenpox. Now, another problem is that vaccine-induced infection can spread to others. So that means if you get your 7-year-old gets a chickenpox vaccine and you take them home, your 3-year-old can come down with chickenpox that comes from that vaccine. And the incidence of developing shingles within 10 years after vaccination has been reported to be almost 1 in 5,000. That's huge. Okay, now what is that about? Okay, and the other part that's really serious is that most adults who are currently immune to chickenpox, because most of us probably had chickenpox as a kid, okay, and even if you didn't have it, if you were around other people who had chickenpox, 99% are immune with a positive history, and up to 93% are immune if they didn't have chickenpox but were around people who had it. Their body just made an immunity to it, made an antibody to it, and they didn't have to manifest the disease, but their body developed long-term protection. And what's really important is that all of us that had chickenpox as a child, in order for us to maintain our lifelong immunity, for us to be able to maintain resistance, we need to get re-exposed to the virus. We need to have our 7- and 9-year-olds get chickenpox so that we get re-exposed to the chickenpox so that our immune system goes, oh, I remember that. I remember that, and kind of beefs up a little bit, gets a little bit of antibody response, a little bit of T-cell long-term immunity response, and then that keeps you protected from getting it over and over again, also keeps you from getting shingles. Okay? And because kids are no longer contracting chickenpox, the natural immunity that adults have to chickenpox is expected to wane. So, October of 2003, this was an article that was published in a mainstream medical journal. 3 different reports looked at cases of shingles and chickenpox that suggest that there's a real threat of a shingles epidemic due to mass vaccination with the chickenpox vaccine, and that children are now experiencing a higher incidence of shingles, and it is predicted that a large-scale shingles epidemic will soon be seen among adults, a group becoming more susceptible to a serious complication. That was published in Vaccine. I mean, that's like the mainstream top of the line vaccination journal that's saying that we are now, and this got a lot of press in the European press, not a lot here. So to solve this problem, what are we doing? Because the vaccine has eliminated the wild virus, humans are the only known reservoir for that particular virus. So the chickenpox is sort of like, like the Hib, the H flu meningitis, the H flu bacteria that the vaccine came along and killed off that bacteria and made it go away. Well, the chickenpox vaccine has attacked the chickenpox virus and made it go away. And because we're not getting that natural boost, our immunity is going to wear off. So manufacturers are planning to license a booster shingles vaccine as a substitute for boosting that occurs naturally from wild chickenpox virus. So now we're creating yet even another problem, another vaccine to protect us against a problem that was caused by a vaccine. I actually had the opportunity to talk to the head of at the CDC, to the gal who was the head researcher for the chickenpox vaccine, because there was a paper that was published that it was just isn't making sense. So I called down there to talk to somebody about it, and they bounced me around until I got to this gal, and she was the first person who told me this. That's the theory now, that our immunity is all going to wane, and that shingles vaccine for adults is now probably in stage 3 at least, or stage 2 clinical trials in Japan to be able to protect us against that. And I said to her, I go, gosh, it just seems as though we ought to let the kids get chickenpox. Well, she had to go. She didn't want to talk after that. I mean, seriously, it was like so far out of her paradigm. But now we are creating more vaccines. Now we had to create the Prevnar because of the Hib, and we had to now we're creating a shingles vaccine because of the chickenpox vaccine. And we're going to talk about another one here in just a couple of minutes. Now this is one of the concerns that comes up, what about chickenpox exposure in pregnant women? Is that a real risk or not? Is that something we have to be really concerned about? Well, first of all, in order for it to be a real risk, you have to have a significant contact. If you're pregnant, you have to have a significant contact with someone who has chickenpox. And how a significant contact is defined is face-to-face contact with someone who has a case of chickenpox for at least 5 minutes, or be in direct contact with somebody for more than an hour. So transient exposure is unlikely to have a significant effect. So that's not a real reality. The definition is considered, and most people are considered immune, and that pregnant women found to be non-immune and have significant exposure, they may want to consider getting vaccine immune globulin or give it to their neonate at birth. And when you actually go through and read all these documents, the whole risk of varicella induced problems with the fetus is really it's so rare that it's almost theoretical. When you go through and you actually read these papers, yes, it happens, but it happens so rarely that it's almost a theoretical risk. So nothing in life is ever zero, but this is probably as close down to zero as you can be. It's not a very real risk.